Hey, all right, and welcome back to DevCamp 2023. So I think we're all well fed and hydrated.
Absolutely.
And I am super excited to announce everyone's favorite Canadian, Adrian Stevens.
Thank you very much, Brian.
And he's going to be going over the IoT lifecycle and talking about, how you get to production from idea. So I think it's idea to production.
Idea to production. Yeah.
Fantastic. Thank you very much, Adrian.
Thank you so much, Brian.
Take it away.
So hello, everyone. And we're talking about IoT lifecycle. And we've seen a lot of amazing technology today, lots of great ways we can innovate with hardware and software. Now we can start thinking about bringing it all together and what it means to actually bring a product into market. So I want to start with a question. So who here has ever had a really great idea? And who here has ever thought, hey, I've got a great idea, and if I could just create it, I can solve a big problem or make someone's life really easy or just do something really cool or, maybe even make some money. Anyone have those ideas? I have. And who's thought, heck, and that's easy. I got this. Not a single hand. And honestly, hardware is hard. Bringing physical things to market is hard. There's a lot of work, a lot of thought, a lot of prep, and a lot of steps. We heard this morning, enterprises today are investing in IoT. They're building things. 85%, I believe we saw, are in the IoT space. And we've heard that a lot of projects are failing. They're failing fast, which is good because they can correct, but they're still failing. It's because hardware isn't easy. So let's see what that lifecycle looks like and how maybe we made that story a little bit easier. So one more question. Does anyone know of a product that took 10 years to go to market? This is a well-known product. It's a bit of a household name. Spoiler, it is an IoT product. And it might even be in your home. And any guesses? Anyone want to yell it out? Any thoughts what the product might be? Took 10 years? What was that? Nest, exactly. 10 years. That's an incredible amount of time. Now, I imagine we've got a lot of software developers here. And if you're like me, you're like, hey, sometimes I sit down the weekend and I build a software product. You're like, 10 years, I can't even comprehend that from a software perspective. I can build an app in a weekend. Hardware, it's a very different story. Now, of course, not all that time is spent building the hardware, but there is a lot of thought and prep that goes into it. And so we'll talk a lot about going from idea to production. And we're going to talk about some lifecycle timelines and some phases. But keep in mind that even what we're talking about here doesn't always include that pre-work, that thinking work, that planning work, where sometimes as developers, we sit down and start coding. Hardware, it's a little bit different. And so we often talk about 24 months. Now, obviously, this is not a firm rule. Some things are faster. Some things that we saw an example are a lot longer. But 24 months, even again, that's way better than 10 years, a lot less than 10 years, but that's still 2 years. And so we want to be very thoughtful on how we go on our hardware lifecycle. And so we're going to cover 5 phases here today. And if you're in the hardware space, you're learning the hardware space, you're going to see some of these terms. And it's interesting, they're not all exactly the same. Some people define them a little bit differently. But roughly speaking, this is going to be pretty accurate of the phases you're going to go through. And we like this terminology, and we're going to start with bench prototype and go all the way to production. So bench prototype, and this is one, we might hear desk prototype. I think of it as my coffee table prototype, where I'm sitting in front of the TV, building a new project. It's that one where you're like, hey, I've got that amazing idea. I've got that idea where I can do something big and amazing. All right, let's get started. So traditionally in hardware, whether you're on a team or you're an individual, you've still got to build it, you have to source it. And we're doing IoT. And so for us that are software developers, we know we have to write the software, but we also have to pick the hardware, assemble the hardware. And I love this example here on the top of the slide. So you can see there's a screen, there's a sensor, and there's some wires. All those things have to be sourced, they have to be put together. You've got to make sure the wiring is correct. All right, I'm going to ask you another question. So who here has built an IoT project from scratch using a breadboard? Who here got the wiring right the first time? Exactly. And I believe this is one of the biggest blockers to building things, because when this doesn't work, why doesn't it work? Is your screen defective? Maybe. Is your power on? You turn it on? Hopefully. Is the wiring right? Does your breadboard work? Or is the software wrong? There's so many things you've got to debug when you're handling hardware. And this is one of the amazing things. We heard about Project Lab, and now we saw the new V3 today. And this is a really great way to accelerate your bench prototype. Now you're not hand assembling all of the hardware. You're not hand wiring. Look at this. This is beautiful. It's got a screen, it's got sensors, and it has tons of extensibility. And it means we take a lot of that guesswork and allows us to take that really amazing idea we have, and maybe it's not the perfect hardware, maybe it doesn't have everything we need, but it's a little bit more like software development now, where we can sit down and start working on our idea and see if it makes sense. Now, bench prototyping, again, this is a common term, desktop prototyping, can be anywhere from a week to a couple of months. And again, depending on the complexity of your system, there isn't a rule here because there's so many different things you build with hardware. But typically think you're gonna put a month or two into this, see if the idea makes sense, see if it's viable. So where do we go from here? Well, back to the idea of digging through the parts bin. Maybe you find the part that works that you have in front of you. Actually, I want to show you an example. If we can hit the camera here, this is actually an early prototype of Wago. That was the gaming handheld we saw earlier. And this is the hand-built version. Let's just get that a little bit more centered. Notice, exactly what we said. We've got a screen, got some wires, got some buttons. And this one I actually built. Why did I put this screen on this breadboard? Because I had it in front of me. It wasn't the best choice. Why did I put 4 buttons? I didn't really want to wire more than 4 buttons. I was running out of space on the breadboard. This is a proof of concept. This is not final hardware, but it was enough to get me up and running. And I'll tell you right now, if Project Lab existed when I built this, I would not have built this. So let's go back to the slides. So we want to go past that phase now into the lab prototype. And this one, it's a little bit fuzzy, but we want to get more into, hey, I've got my idea working. I've got a sense of what hardware I want. I probably have a good idea of what maybe we're going to look at production. It's still a long ways off, but I've got a sense of I know what I need, and I'm starting to sense the shape of the project. Again, lots of variation here. If you've got something that's taking human interface, it's a human interface device, has inputs. Well, that's the number of buttons maybe, or the type of inputs, or the display. If it's something that's embedded in a system, well, that's the right sensors. And here, we're going to start testing the product and starting to get hopefully some real-world data. Does it work? And we're going to probably do internal testing. We're going to hand out the team. We're going to build a few of these. We're not building mass market because we know we're not final yet. We might still be using breadboards, hand assembly, or we might even go into low volume PCB production. And I want to show you another piece of hardware here. It's actually another version of Wago. And this is another fun example. So this is a case of, hey, we start building this. We're like, hey, we've got a sense of what we want to notice the screen isn't too different. We've got some buttons. We changed the configuration. We actually added an analog joystick. And there's some things that are interesting here. I'm going to see how well this works. But you notice there's actually lots of extra holes here. This was designed so we could swap out displays. Didn't quite have it finalized. We're starting to get a little closer. Starting to get a sense of 3D printed buttons. So it's a bit homemade, but starting to look more like a physical thing. Certainly more than the hand-assembled breadboard. So start to test it. Start to see if it works. Maybe make some hardware revisions. Now we move into the field prototype, and this is where things get exciting, right? We've been through a couple iterations, want to get it out in the field and go, real world use cases, something we think is looking like a final product. Does it do what we want to do? If we haven't done custom printed circuit boards, custom PCBs yet, now is the time. This is an example of Klima. And although we don't see a PCB here, I'll tell you in that little white case on the post, there is a printed circuit board powered by Meadow, of course. And this is where we're going to start building some custom hardware. I can use the Wago example just because it's fun. I love this story, something that's near and dear to me. We show the hardware again. So notice this is similar to the previous version, but it's looking a lot more refined. Changed the display. We've finalized the design. This is a nice color display here. These are actually off-the-shelf commercial buttons instead of 3D printed. A little more polished. Little more field ready. Again, for enterprise or embedded systems, it might be tucked away in a custom enclosure. And again, we're doing lower volume, but we're definitely doing custom hardware. So notice we're no longer using Project Lab or an IoT accelerator. This is where you're going to start building your custom hardware. But here's the fun thing with Meadow and Wilderness Labs. We've written software. We haven't talked a whole lot about the C# and .NET, but we've written our application on those previous iterations. Now we're migrating to hardware, migrating to different hardware design. Because of the composable nature of Meadow Foundation, all the sensors conform to interfaces. We can swap out hardware and we can reuse the same code, the same application that we used in our previous iterations and modify it for new hardware. Again, rapidly accelerating our time to this phase. You still got to build it, you still need to test it, but we can make that transition easier and make this not a big sticking point. And then we get into production beta, and this is where we want to get things into the hands of actual customers, likely a closed beta, but we want people using it in real world scenarios. So notice we've got a couple examples here where we got things in actual cases, and I love it. We got our little GNS tracker here out in the wild, running off battery, unsupervised. Let customers use it, not in a constrained environment where the developers are hovering over it. Let's see how it reacts in the wild or how our customers use it, find those edge cases. At this point, we probably think we have a final design. We'll probably learn that it's not quite final, but we'll be getting close, and it's going to look like our end product. We might go higher volume here. It's going to depend on the project. I know I've said that a lot. It could be building 50 versions. If you're doing something that's a smaller device that has to go in a lot of places, maybe even building 1,000 of these, sending it to a lot of customers, but getting real world feedback, not monitoring it by the minute, by the hour. And then we get into our exciting phase, into our volume production. And I want to show you some hardware here too. So I want to show you the next iteration of Wago here, and this is fun. So we got into our last phase here. We learned a few things, and notice we did some edits. So we actually took away the analog joystick, realized we didn't need it, realized the display is actually a really important part of this hardware design. So we wanted a larger display. Funny that, for an entertainment device, that's an important part. Got closer to that final form factor. And again, you see some edits, but now it's something where custom printed circuit board, no more bodge wires, no more variable, more of a complete design, and feeling close to a final product. So for volume production, well, now is the time to be optimizing. You've got your data, you've got your customer feedback, and hopefully you've got yourself a winner, but you know you're at a place where you can go to production. Again, we're building on Meadow, so we're not rewriting our applications from phase to phase. We're updating our hardware, we're updating our software, but we're doing iterative work, and we're revising and refining our product, taking our testing feedback, incorporating it to make it a better product. And then this is the phase here where it really is volume and optimization. We're gonna make those final edits to our hardware and software. Software, get all that debug code out of there, make it fast and efficient. Hardware, we'll remove anything we don't need. We might make some last minute swaps to optimize for cost, optimize for size, get it in the field. We know we've got the data, we know we've got a product that's gonna work. And then of course, we know that at V1, we're done, right? No more iterations, that's it, hardware V1 shift. No, of course not. There's probably a V2 to V3 coming, but at least we know we've got a product in market that's able to perform. And I'll show you just because I love the story. Let's just do our Wago here for our comparison to our last one. And again, it's even a good story here where we've shrunken that PCB down, done some optimization here. And then for an actual production product here, hey, we want to have a case if we're actually making this a retail gaming system, case, documentation, packaging. But of course, for the purposes of an IoT accelerator, well, actually, this is perfect. This is ready to go. And it's true. This is going to go in the store, and it's going to be available for sale. So we'll talk a little bit about economics and what you need to expect to spend on each phase. Now, for those who use of software, we think about as our time. Well, for hardware, there are some costs. You know, for that bench prototype, that one where I'm either hand assembling or maybe working on a project lab, couple $100 in hardware for each one. Going to build a couple of those, find that it works, move on. Again, this cost is highly variable. If you've got an expensive sensor, well, that cost is going to go up. If you've got a really simplistic design, hey, that cost can go down. Get into our lab prototypes. And what I like really about this slide here is talking about the volume of production as well. So we're thinking 5, 10 maybe. And we might spend a lot more. And you're like, well, why did the cost just jump up? Well, it's going to depend on how you're assembling this. But if we're building custom printed circuit board this phase, well, at this low volume, they're probably still hand-assembled PCBs. So you're getting the circuit boards printed, but you've got to get all those parts on there. And so there's some labor costs in building these. And that's worth keeping in mind. Now, that could be your time. With a soldering iron, you might have some specialized equipment to help get those parts installed on PCB, but you're probably not getting a manufacturer to mount all the parts onto your PCB at this volume. Or if you are, you're going to pay for it. So it's a little bit more expensive. Same thing to our field prototype. Again, we're looking at some slightly higher cost because we're low volume. But when we get into production beta, well, this is actually a lot of fun because this is where the costs start to come down because we are doing some volume. We can get volume assembly, and we'll probably optimize our hardware too. We might be removing things we don't need. So we're starting the optimization on the hardware, on the bill of materials, and the optimization on the scale of assembly. And then of course, production. Again, we're just picking numbers here, 50 bucks, might even go lower if we're thinking about a $100 end user product. But we're getting economy of scale here. And so we see it really does trend downward, a little bit upfront cost. But if you look at this, the actual total cost here, it's a few $1,000s until we go to high volume production. So it's not crazy amounts of money, but we want to, if we're a smaller company, we want to be careful with every dollar we spend, and we want to make sure we get the most out of every phase. So production pro tips, yeah. So I think you kind of got this, but we do really believe that using Meadow is going to save you time, especially if you have a project where these IoT accelerators can save you that assembly time and get you iterating faster on your bench prototypes. And then, of course, the software layers where there's a lot of magic happening to allow you to switch parts, switch sensors, iterate on your hardware revisions a lot faster, and get a lot of that testing and a lot of that learning done in those early phases. So when you're into your later phases of production, you're not discovering those edge case bugs. So yeah, I kind of gave it away, right? IoT accelerators, Project Lab, great tool here when it's the right tool for your project, and it's going to match a lot of them. Oh, and of course, the off-the-shelf modules, I almost forgot. So Brian talked about this earlier today, too. This is another really big one. So things like solar power management, things like Ethernet connectivity, if that's what you need for your solution. These are harder problems to solve. And all these things require custom hardware. Standard modules you can get from Wilderness Labs and embed those directly onto your builds. You're not spending the R&D cost on these standard components, and they work with the platform. It's just going to make your life easier. And when it's the right fit, it's a huge, huge time and cost saver. And I mentioned this already as well. Because the modularity of both the hardware and the software, we're doing better testing on every phase of life cycle, hopefully reducing bugs, getting you to market faster. So thank you very much. And how are we for time? Are there any questions? I know this is a hot topic. And also we have some experts here too. Fantastic. Well, we're here. So for those of you who are watching online, join the Slack and come ask us some questions. Send us emails. And for those of you here in person, come talk to us. Wilderness Labs folks all around would love to talk hardware and software. Thank you very much.